Okay, so in today's video we're going to be having a look at the cosine rule. Now again, in this video we're not going to be having a look at the why and how the cosine rule works. Again, that video is going to be in the description on proving the trigonometric rules, but we're just going to look at actually applying it and sort of how we would use it in an exam situation and on some of these sorts of questions. So obviously you do need to know the cosine rule, so it's one that you have to remember. So if we're going to write that down, and we're going to write it down for every question, it's a squared equals b squared plus c squared. And up to this point it looks quite similar to Pythagoras' theorem, obviously a rearrangement of the letters there, but obviously it does look fairly similar. So once we've done that bit, we just do minus 2bc cos a. And there are obviously two other different rearrangements of that. We could have b at the start and obviously swapping the a's and b's around, or we could have c at the start, swapping the a's and c's around there. But we're going to be using this throughout the video, so grab a piece of paper, grab a pen, make some notes, and we're going to get started on using this formula. So this question says find the length of the side BC, which I'm going to label as x, which is this side down here. And it says give your answer correct to three significant figures. Now we'll worry about that at the end. And for the moment, obviously we've got all these a's and b's. Now, very similar to obviously with the sine rule, we're just going to label this triangle up, but I'm going to label it in a very specific way now. Rather than learning three variations of the formula, I am just going to use this one formula, but that does mean I do need to label one side with one particular letter. Now, obviously this formula here that we're going to use is for A, and the side that we're looking for is this one down here. So this side here I'm going to label as my A. So to kick this off, I'm just going to label that A, obviously my little a for the sides there as discussed in the previous video. Now looking at that, we need to find our opposite to that, which is obviously up here if I point an arrow to it, and that's going to be my big A. Now that does already have an A next to it, but don't let these letters dictate how you label your triangle. So I'm going to cross that out, and I know it already said big A, but I'm just going to put my own big A in there. Again, obviously the question does have B and C on the other angles there, so it's completely up to you. Just to show you, I'm going to cross off the B, I'm going to call that one C. I'm going to cross off the C, I'm going to call that one B, because I don't let the sides, what's given to me in the question dictate how I label it. I label it however I want to label it. So opposite the B, that's going to be my little b, and opposite the big C, we've got our little c there. And the rest now is just putting these numbers into the formula. So obviously our formula there is for a squared, so I'm going to keep that as x squared or a squared. You can leave it however you like, but that's going to be x squared. So x squared in place of a, and that equals, what have we got, b squared. B over there is 4.8, so 4.8 squared, plus 6.4 squared, my value of c, and then we're going to minus two lots of bc cos a, so minus 2 times b, which is 4.8, times c, which is 6.4, and that is, I'm just going to slot that underneath, cos, there we go, and that's 123 degrees there. I'm going to put that in a bracket. Right, there we go. So we've got 4.8 squared plus 6.4 squared minus 2 times 4.8 times 6.4 cos 123. Now obviously this is a calculator question, so I'm just going to type that into the calculator and see what I get. So 4.8 squared plus 6.4 squared, take away 2 times 4.8 times 6.4 cos 123, closing the bracket there and press equals. Now that does give me a value now, so that's absolutely fine. So now we've got x squared, I'm going to go around that, not drawn accurately, so x squared is equal to this number on my calculator, which is 97.46, and a lot more decimals there, so I'm just going to leave out writing those. Now I'm going to leave that answer on my calculator screen, and obviously I don't want to get any rounding errors here because it wants it to three significant figures, so I'm going to leave that on my calculator display, but we want the value of x, not x squared, so I just need to square root both sides there. So if I square root both sides, obviously that gives me a value for x. I'm just going to put a square root symbol over the top. So that's going to give me x equals, and the way I'm going to do this on my calculator, I'm going to press the square root button, press your answer button so it square roots that previous answer, and then press equals, and there we go, I'll get x equals 9.87. It wants it to three significant figures, so I'm going to write my answer to 4, the next numbers are 2. There we go, and obviously then we can round that, so just rounding that after the third significant figure there, which is the 7, after that is a 2, so that is not going to round up that 7 there, so my answer is going to be x equals, or a equals, whichever one we're looking at there, x equals 9.87. 7, and what units are we looking at? Centimetres, there we go, so 9.87 centimetres. So as long as you know your formula, obviously it's just as easy as sticking the numbers in, as long as you know how to label the triangle there. Again, just remembering the side that you're looking for, we're going to call that A, and then we don't have to learn 3 variations of the formula. We can just obviously just learn the one, okay, because obviously you've got enough formulas to learn, so you just want to minimise the amount of formulas that you're actually learning there. But there we go, that's how to use the cosine rule. Quite nice and easy. Once you plug the numbers in, you've just got to remember obviously that you are finding a squared or x squared in this case, so our final step there was to square root, which is again a lot of similarity to, you know, our Pythagoras there with our a squared equals b squared plus c squared, and obviously our square rooting at the end. There's just that additional part of the formula, the minus 2bc cos a, that you actually have to learn there. That's you know, quite different obviously to Pythagoras. And obviously with Pythagoras it's obviously only focused on right angled triangles, and cosine rule we are using for non-right angled triangles as well. Let's have a look at another question. Okay, so this question says find the length of AC, and again giving your answer to 3 significant figures. Now AC is this length over here, which we can call x, or in this case I'm just going to call it A, because that's going to be my A there, the side that we're looking for. So straight away I'm going to call that A, and I'm going to start labelling up this triangle. And again, look, there's a B opposite that, so we'll forget that, and we'll call that our big A. Now it doesn't really matter with the other ones, let's just keep the C as it is, and let's put the B over here, and then let's just obviously label our opposite sides there appropriately, opposite the B's and C's. Now straight away let's just plug that into the formula. So A squared equals b squared, which is my 28.3, so 28.3 squared, plus c squared, which is 11.7, so 11.7 squared, minus 2 times bc cos a, so b is 28.3, times c, which is 11.7, and then again fitting that underneath, cos, and opposite that was 67 degrees there, so my a is 67, so cos 67, again I'll just put that angle in the bracket there, as most calculators will do that for you. Right, so let's type that in. 28.3 squared plus 11.7 squared minus 2 times 28.3 times 11.7 cos 67, close brackets, press equals. We get the value for a squared of, let's have a look, 679.03, and a few more decimals there. But again, obviously we want to finish this off by square rooting it, so if I square root the answer there, so square root answer, and that equals 26.05, and what's after that? 82, so 0582. Now rounding that to 3 significant figures to finish this off, let's have a look. The third significant figure there is the 0, so that's going to become 26.1, because a 5 after the 0 there rounds that up, so 26.1, this is in metres, so 26.1 metres there, for obviously for our value of A up here. There we go, and there's our final answer. Okay, so obviously you need to know the formula quite well, but I think as long as you're happy just labelling the side you're looking for as A, it's quite easy then just to plug all the values in, and obviously not forgetting to square root it at the end. So here's a couple of questions for you to have a go at. Okay, so pause the video there, have a go, and we'll go over the answer in a sec. Right, okay, so for the first one, this is going to be our A, the length of BC. So we've got a big A, and obviously you might have labelled these slightly differently, but let's keep it in line with the letters now. So that'll be little b, this will be little c. Now there we go, I don't even really need to relabel those, but I'll write them on anyway. So A squared, see if I can fit all this in somewhere. So we've got A squared equals 7 squared plus 5 squared minus 2 times 7 times 5 cos, and that's 42 degrees we're using there in the question. There we go, let's type that all in. So 7 squared plus 5 squared minus 2 times 7 times 5 cos 42, close the brackets, press equals. There we go, and we've got A squared equals 21.979 and a few more decimals, and I'm finishing that off, square root answer, and we get a final answer here for A of 4.688 with some more decimals, but obviously we want to finish it off by rounding it to 3 significant figures like we've been asked in the question. So that's after that first 8 there. So our final answer for that question is 4.69, and again that's in meters, so 4.69 meters. There we go, and there's our final answer for the first one. On to the second one. We're looking for the length of AB, so this will be my A. There we go, and then let's stick with the little b, and we'll relabel this one C. There we go. So Typing all this in, what have we got? A squared equals 15 squared for B plus 12 squared minus 2 times 15 times 12 cos 20 in this case. There we go, 20 degrees. Right, let's type that all in. So 15 squared plus 12 squared. What have we got next? Minus 2 times 15 times 12 cos 20. There we go. Equals after closing the bracket. So we get A squared equals 30.71. A few more decimals, and let's square root that, and that finishes it off. We've got A equals 5.54. There we go, it's a 1 after the 4, so that's already to 3 significant figures there, and that's in centimetres. There we go, so 5.54 is our final answer, and that's those 2 questions dealt with. Now for the next one, we're going to have a look at finding angles, so let's have a look at that. Now when it comes to finding angles, there are 2 rearrangements of the formula that we can do, and I'm just going to discuss the both of them obviously, because there are 2 different ones that we can look at, but there's one in particular that I'm going to be using. So for A squared equals B squared, let's have a look, plus C squared minus 2bc cos A. There we go. Now what I want to have on its own is the A really, or the cos A. So what we're going to do is we're going to rearrange this so that cos A is the subject of the formula. And there's 2 ways of doing that, and I'm going to do it the easier way first, and then, well, actually I'm going to show you the mathematical way first, then I'll show you the easy way. So obviously what we want is to minimise the amount of negatives that we've got in our fraction here. So the first thing that I'm going to do is I'm going to move this entire negative piece, this minus 2bc cos A, over to the other side. Now if I do that, I get A squared plus 2bc cos A. There we go. And that equals b squared plus c squared. Now what I can do is I can move this a squared over to the other side, obviously starting to get the a cos A on its own. So we get 2bc cos A equals b squared plus c squared minus a squared. And then just to finish it off, I'm just going to divide by 2bc, and that will leave cos A on its own. So we get cos A equals b squared plus c squared minus a squared all over 2bc. So it's completely up to you. You can just learn this formula if you want, or you can just learn to rearrange it. Now that is obviously the best way to rearrange it there, because we minimise the amount of negatives, but there is actually another way of rearranging this formula. So if I look at that over here to the side, what I could do is I could just minus that b squared and c squared right on the first step. So I can have a squared minus b squared minus c squared, and that's going to equal negative 2bc cos A. Just about fit that in. Okay, and then just straight away I can actually just divide by this negative 2bc just to leave cos on its own. So I can have a squared minus b squared minus c squared all over negative 2bc, and that all equals cos A as well. Okay, so obviously it's a little bit quicker. There's one less step, but it's not quite as nice mathematically because we've got that negative 2bc on the bottom. But it's absolutely fine to do that as well. If you're struggling to rearrange this and you just prefer just to get it all over in one go and just reduce it by 1 step, then that's absolutely fine. But there we go. Obviously you can just learn that formula, but that's how to rearrange it and make sure that you're sort of confident doing that. It's quite a good skill, obviously, being able to rearrange formulas anyway. So there's one for you to be thinking about. Now what I'm going to do is I'm going to stick with the one on the left, the one that I did first, and I'm just going to be plugging the numbers in and using it. So it's completely up to you which one you decide to use, but I'm going to stick with using this one. Okay, so I'm going to stick with this one. I'm going to put that up the top here. There we go. And we are just going to stick the numbers into this formula again. So it says work out the size of angle X, and again I'm going to call that A, obviously cos A there in my formula, so I'm going to label the angle I'm looking for A. That means that this has to be little a, but the others I'm free to call whatever I like, so this can be B and C, and again we can label this up if we want with our big angles B and C. So if we stick our numbers in, we get cos A equals, let's have a look, b squared is 15, so 15 squared plus c squared, which is 16, so 16 squared minus 20 squared, which is my a squared, and that's all over 2 times b times c, so b is 15, c is 16, and there we go, and let's stick that into the calculator. So 15 squared plus 16 squared minus 20 squared, and that's all over 2 times 15 times 16. Press equals, and you get a fraction, so let's convert that into a decimal. So we get cos A equals 0.16875. Now obviously that's not the size of the angle, but thinking back to obviously normal trigonometry here, this is obviously not a at the start, it's cos a. So obviously if we want to tell our calculator that this time we're looking for the angle and not just that little relationship there, we need to do our inverse of cos. So I'm going to leave that number on my calculator, I'm going to press shift cos, which obviously brings up cos minus 1. So we get cos minus 1 to find our inverse, and I want to just make sure that this entire answer goes into that, so I'm in the bracket, I'm just going to press the answer button again. So cos minus 1 of my answer, press equals, and there we go, let's write that down here, and we get 80.2848, a few more decimals, but it wants it to 3 significant figures, so let's chop that after the 2, which is our third one there, and we get 80.3, because it's an 8 it rounds up, so 80.3 degrees there for the size of that angle, and there's our final answer. Okay, so obviously very, very similar. Obviously you've got to learn this formula up here, so this is obviously a key one to make sure that you've got written down. B squared plus C squared minus A squared all over 2BC. But again, it's nice and easy, just obviously labelling the angle that you're looking for as your A, this one here, and then just sticking all the other numbers into your formula. Just remembering at the end there, just like with all forms of trigonometry, when we're looking for an angle, we do the inverse there, just like in the sine rule, just like when we're looking at SOHCAHTOA. When you're finding an angle, you always use that inverse, so that stays consistent throughout all of these bits of trigonometry. Okay, so there's a question. Now here's two for you to have a go at. Okay, so there's two questions for you to have a go at here. Obviously make sure that you've written down that formula and you're just practicing obviously using it. Obviously in your own time, obviously go away and make sure that you can actually learn that, but for now just focus on actually sort of putting it into practice and having a go at using the formula. So here they are, two questions, pause the video there, we'll go over the answers in a sec. Right, okay, so this first one we're looking at the size of angle ABC. So ABC is down here, so that's going to be the angle that we're looking for. That is obviously opposite the 10 there. So let's label this up, that's my A, and then my little a, we'll keep this as C, and we'll turn this into B. There we go. So let's put that all into the formula. So obviously not forgetting that formula there, we've got B squared plus C squared minus A squared all over 2BC. And that is the cos A. There we are. And if we put all those values in, let's see what we get. We get 9 squared plus 5 squared minus 10 squared all over 2 times 9 times 5. Let's put that into the calculator. So 9 squared plus 5 squared minus 10 squared, and on the bottom there 2 times 9 times 5. There we go, we get a value 0.06 recurring. So cos A equals 0.06 recurring. Let's have a look, let's just write that down. So cos A equals 0.06 recurring, and then we'll do the cos minus 1 of the answer there. So shift cos, answer, close the bracket, and we get 86.17, no, it wants it to 3 significant figures, so it's 17, so that rounds to 2, so 86.2 degrees, and that's our final answer there for the first one. There we go, let's highlight that off. And for the next one, let's have a look. So we've got our angle up here, so that's A, and then B and C in either order over here. I won't label the coordinates this time. So if I stick them into obviously that formula, which is obviously already written over here, we've got B squared, let's get rid of that, that's a bit of a dodgy arrow. There we go, so B squared, which is 21, so 21 squared, plus C squared, which is 13 squared, minus 24 squared, and that's all over 2BC. So 2 times 21 times 13, and let's type that all in. So on the top, 21 squared, plus 13 squared, minus 24 squared, and on the bottom 2 times 21 times 13. There we go, press equals, and we get, oh, not a very nice decimal. So let's have a look, let's write that down. So cos A equals 0.062271, 2271, and there's a recurring pattern here above the 0 and the 1. So there we go, a recurring pattern there of 6 decimals. Not forgetting that just means that the 0.62271 is repeating over and over and over again. So let's do our cos minus 1, obviously, of the answer there. You want to make sure that you're happy using this answer button, because you don't really want to be typing that in over and over again. And it's not the nicest one to type in, so shift cos, answer, and press equals. Let's have a look, and we're going to round this straight away. So it's 86 point, and then it's 42, so just 4 there, because that 2 is not going to round that up. There we go, so 86.4 degrees. There we go, and let's highlight that off as our final answer. Right, brilliant. Let's have a look at something slightly different then. Okay, so something a little bit different here. It says calculate the length of QR. Now QR is this length over here, so let's label that. There we go, that's QR. Now at the moment, we don't have the opposite angle. In fact, we don't really have much in this triangle. We have the 14 and that is actually it. But we have got these parallel lines going on, okay? So hopefully we're going to be looking at some parallel line rules here. So something a little bit different. And we have got this right angled triangle, SPR, on the left there. Now on the right angled triangle, we've got the length of 8 and an angle. So obviously we can use SOHCAHTOA or potentially the sine rule or something like that to work out one of the missing lengths. Now this one obviously stands out to me because if we can work that one out, that gives us another length in our little triangle on the right there. So let's think how we could do that. So thinking about some trigonometry again, some SOHCAHTOA, we've got this side here which is our opposite. So we've got the opposite and we're looking for the hypotenuse. So we can definitely use SOHCAHTOA to do this. Again, obviously, if you're using formula triangles, let's have a think, SOH. So if we're looking for the hypotenuse, we're going to do the opposite divided by sine 62. So I can work that out, definitely. Let's call that hypotenuse there. Let's just call it the question mark to be fair. So the question mark is going to equal the opposite, which is 8, divided by sine 62. There we go, so sine 62. So let's type that in, 8 divided by sine 62. And that equals 9.06. Let's have a look. So that equals 9.06. And there's a few more decimals. I'm going to leave it like that. This question doesn't actually say. Let's just go for 2 decimal places. Let's go for that. There we go. We're going to do 2 decimal places. So let's label that on the diagram. So we've got 9.06. And obviously if I'm doing it to 2 decimal places, I should probably keep it a little bit more accurate. So it's 0.6056. There we go. But I'm going to keep the answer on my calculator anyway and use that. Now let's look at this right triangle on the right now. Now I have got 2 sides, but yet I'm still missing the angle opposite the one I'm looking for. So there must be something to do with the parallel lines here. And if we have a look, let's just try and highlight this. We actually do have an alternate angle here. So going along our parallel line, it jumps up to here. Moves along, so we've got an alternate angle there. So this particular angle here is alternate with the 62, so that one is also 62 degrees. And now we have all the information that we need in order to use the cosine rule. So opposite that we've got the little a, so this would be our big A, and then these will be our B and C. Let's have a look, and the one that we've just made there will be our C. So we can type that straight into the cosine rule. Obviously not looking at angles here, but we might be looking at angles potentially. But this one's looking for a side length, so A squared equals b squared, so 14 squared, plus c squared, which is that 9.06. And again, I'm going to leave that in my calculator so I can use that in a sec. And that's squared, minus 2 times 14 times c, which is this 9.06 number. Ooh, 06, there we go. And that's going to be cos 62. Right, there we go. So let's try typing this in. So obviously I've left that answer in my calculator. So 14 squared plus answer squared minus 2 times 14 times answer, and then cos 62. Again, you can just write it down and not use the answer button if you want. I just quite like just actually using that. So let's have a look. So let's write what we get here. So a squared equals, press equals, we get 158.9908. There we go, 9908. And there are a few more decimals, but again, we'll leave the answer on my screen. So let's square root that. So our value of A, square root answer, and that leaves us with a final value here of 12.609 with a few more decimals. But if we do have that 2 decimal places for this question, that'd be 12.61. And this is all about centimetres. There we go, so 12.61 centimetres, our final answer. So obviously a lot going on in that question. We had some SOHCAHTOA, which, you know, in a different kind of question, could be looking for an angle, it could be looking for a side length, and then we had to apply some cosine rule. And obviously there was a little bit of parallel lines going on in that one as well. So something a little bit different with a blend of different topics, but just something to be thinking about how you could apply this topic, you know, within a different sort of setting or a different sort of diagram that's not just a plain triangle. I've got one for you to have a go at here. Obviously not the same sort of style, but a similar sort of idea where it's just something a little bit different, you know, it's not just a plain triangle. Okay, so have a go at this one. Okay, so here's your question. Calculate the length of, that should not say the length of x. Calculate the size of angle x. Let's cross that out. There we go. Calculate the size of x, or the size of angle x, and give your answer correct to 1 decimal place. Okay, so pause the video there, have a go, see what you make of it, and we'll go over the answer in a sec. Okay, so for this question then, let's have a look. So on the right, so we've got a right angled triangle, but we've only got one length down here, so we need another piece of information. And obviously this is our connecting line here, so let's see if we can figure out the size of that. Now the triangle on the left there, we've got our angle of 40, let's call that A, and obviously that question mark there is opposite that, so that would work for cosine rule there, because we've got B and C just here. So if we work that out using the cosine rule then, let's have a look. We've got A squared equals B squared plus C squared, so 13 squared plus 10 squared minus 2 times 13 times, let's get rid of that out of the way, put that underneath, there we go, times 13 times 10 cos 40. There we go, and let's type that in. So 13 squared plus 10 squared minus 2 times 13 times 10 cos 40. There we go, so for A squared we get 69.828 and a few more decimals, but let's square root that and we get a final answer for A of 8.356. There we go, I've left that to 4 significant figures there, but I'm going to leave it on my calculator display. So 8.356 with a few more decimals. Right, okay, so looking at the triangle on the right, we can work out that angle now. So using SOHCAHTOA, we've got the opposite there, that's our opposite, and the 5 there is our adjacent. We're not really using the hypotenuse here, so we're going to use tan for this. And again, if you're using formula triangles, there we go, TOA, and we're looking for the angle. So we're going to do tan minus 1 when we're looking for an angle. So tan minus 1, opposite divided by adjacent. So we've got 8.356 divided by 5. And again, I'm going to type in the answer button here when I do this. So shift tan and press my fraction button, and I've got answer divided by 5. There we go, my 5 kind of looks like a 6, so I'm going to rewrite that because I'll probably end up putting 6 in if I don't, so I'm going to rewrite that as a 5. There we go, and come out of that and close the bracket and press equals. There we go, and we get a final answer here of 59.105 with a few more decimals. So to 1 decimal place, that's 59.1 degrees. And there we go, there's our final answer. Awesome. Now, before we finish, I've got one more question for us to have a look at, looking at using the cosine rule with some algebraic side lengths. So I'm going to go to that question. That's going to be our final question on this topic. So here it is. Okay, so this question says work out the value of x. Obviously, it doesn't really give any indication of using the cosine rule. So a question like this, obviously, we could be looking at thinking about the sine rule, could be the cosine rule. But for this particular question, let's have a look at why it would be the cosine rule. So obviously, we've got our angle of 60 there. We've got the side opposite that. And then we've got 2 sides that are adjacent to that here. So we could say that this is our little a, and then this is our B and C, and we've got enough information there to plug that into the cosine rule. So it doesn't jump out as being a cosine rule question, but if we just stick all these pieces in and see what happens, hopefully you'll see that this is quite clearly, only something that we could really solve using the cosine rule. So let's have a look. So if we put them all in, so we've got a squared, so we've got 2 root 7, and that's squared, and that equals b squared, which is 2x minus 1 squared, and that was plus, probably best to write the formula down here because I get a little bit lost when I'm sort of trying to do this all in my head. So 2x plus 1 in brackets squared, and then minus 2bc cos a. I'm going to run out of space here, so 2 times b, b is 2x minus 1, c is 2x plus 1, cos a, so cos 60. Right, so we've got a lot going on in this question. Now I've got to sort out this first bit, which is a third. I've got to sort out all these double brackets here. I've got to sort out this big bracket here, and I've got to figure out what cos 60 is. This actually is a non-calculator question. Okay, and there's, it could be a calculator as well, but cos 60 is one of those values that you need to know. Now, I've done a video on finding the exact values of trigonometry, but I would say that cos 60, and again, that video is in the description, but I would say that cos 60 was one that you should know, and the value of that is 1/2 or 0.5. Okay, but obviously check out that video if you're not sure on your exact values of trigonometry yet. But if we tidy all this up, look, we get 2 root 7 squared, which is 4 times root 49, or 4 root 7. Again, if you're not sure on your surds, obviously go check out my surds videos. But 2 root 7 times 2 root 7 is 4 times 7, which is 28. So we get 28 for the value of that. Okay, and that equals, Now 2x minus 1 squared, I'm going to do these relatively quickly, but I'm going to keep it in a bracket because obviously we've got so many of these. That comes out as 4x squared, 2x times 2x is 4x squared, minus 2x, and minus 4x plus 1. There we go. And we're going to add to that the next one squared. I'm going to write this underneath. So 2x plus 1 squared is 4x squared plus 4x plus 1. And then we're going to take away 2 times that bracket squared times cos 60. Now there's a little trick you can do here. And we've got a 2 at the start, and we're going to eventually times that by a half, or this half up here. Now if we do 2 times a half, that becomes 1. So actually they cancel each other out. So 2 times a half is 1. So actually if we do that to start with, obviously remember you can times things together in any order, it doesn't really matter. Just thinking about basic sums, if we do 2 times 3 times 5, just from random numbers, it's the same as doing 5 times 2 times 3. Okay, it doesn't actually matter what order you do them in, so I'm just choosing to do them in that order just to help me out a little bit there. So 2 times a half is 1, so actually I don't need to worry about that. I can just focus on this double bracket here, which I'm going to be taking away. So then I'm going to be taking away and expanding that. We get 2x times 2x, which is 4x squared. We've got a plus 2x and a minus 2x, so they cancel each other out, and then a minus 1. There we go. And I've kept it all in brackets here because obviously we are taking away or adding together full quadratics there, so I just need to be wary of that with all the pieces. So let's have a look at these and break this down. So I've got 4x squared. I'm going to add to that another 4x squared, which is 8x squared, and I'm going to take away this final x squared. So we've got 8x squared, take away 4x squared, which leaves us with 4x squared. Okay, let's put this 28 back at the start. So 28 equals 4x squared. Now let's have a look at the next pieces. So we've got negative 4x, add 4x, which gets us to 0, and no more x's, so there we go, that's 0, so I can just leave that, forget about that, that's done. Now the numbers, we've got plus 1, add 1, add positive 1, so that's 2, and then we're going to take away negative 1, and this is the point here where you might make a mistake because we're taking away negative 1, which adds another 1, so we've got 1 plus 1, and then another plus 1, which gets us plus 3. There we go, so we've got 4x squared plus 3 that equals 28. Now it might be that you have to use, this question could be really difficult. We could have to do some factorising, we could even have to use the quadratic formula, but actually this has come out as quite a nice one here. I can take away 3 from both sides, and I get 25 equals 4x squared. There we go. Then we can divide by 4. Let's have a look. Let's just move this up here. So divide both sides by 4. We get x squared equals 25 over 4, which is 6.25. And then square rooting that, you get x equals 2.5. Now to be fair, not many people are going to know that off the top of their head. So let me just explain another way of doing that. I've just realised that I've just done all that in my head. Right, so x equals 2.5. That's our final answer. Let's have a look at how we could do that without a calculator though. So obviously x squared, I'm going to bring this up here. X squared equals 25 divided by 4. So let's leave that as a fraction. 25 over 4. There we go. That's x squared. And then we're going to square root it. So if we square root the both of those, you get 5 on the top, 2 on the bottom. And 5 divided by 2 is 2.5. There you go. So obviously, if it is non-calculator, you're employing some sort of higher level skills there, obviously thinking about the way you do that final step, which is always quite nasty when you haven't got a calculator. But if you do have a calculator, obviously that's quite nice and easy there. But obviously you could have had something a little bit trickier in this question. We could have had some x values in the middle, had to make it equal 0, had to factorise it, potentially had to use the quadratic formula. It just depends how difficult the question is there. But there's just an idea about how you could apply, obviously, the cosine rule to a question here. We've got some algebraic lengths. But that is the last question. That was well done for sticking through it because that is quite a tough one to finish on. But that's the end of the cosine rule. So if you found that useful, if it was helpful, please like, please comment, please subscribe, and I will see you for the next one.